So here's the PHET simulation for EM waves, radio waves, and EM fields. Here's a transmitter, here's a receiver, a transmitting antenna, a receiving antenna. There's a voltage source that drives a current that drives the electron up and down the antenna here. That propagates a wave, an electric field that propagates toward the receiver. The electron here responds to that electric field, moves up and down. That makes a current flow down to the receiver, which can be detected, demodulated, and turned into information. So if I move the electron here, I propagate a traveling wave, an EM wave that goes that way, and you can see the electron bounce up and down a little bit there, but I'll oscillate it regularly up and down, and you can see once the wave gets here, the electron starts to respond to that field. Like any wave, there's a relationship between the frequency and the wavelength. Here's a kind of a high frequency wave. If I make the frequency smaller, the wavelength's going to get bigger. So that's maybe too slow. Let's make it somewhere in here. So there's a lower frequency, longer wavelength mode. If I increase the amplitude of the wave, I can get a bigger response back here. There are two ways to transmit information. I can either change the amplitude of the wave in real time and detect that as an audio signal, say, or I could change the frequency. You know about AM radio and FM radio. Those are two different ways of modulating. Both lead to signals that can be detected. FM radios have a better fidelity because of less interference from atmospherics. So that's the simple picture. This app can be very more information than you perhaps know. This is plotting here just the envelope of the electric field in the direction from the transmitter directly, but of course this radiates in all directions, so the full field goes back and forth like that, and I get more signal strength here than that way. That's kind of polarization. There's stronger field strength going this way than that way. Just a quick brief introduction to EM waves.